Hello friends, let's continue our series. We're solving the problems on the queue data structure, and we are now going to be solving problem number 3. And in this problem I have here the queue, and the queue is going to be actually implemented using stacks. So we will be going to use two stacks to form a queue, and after our operation is complete we will be able to implement the operations of our queue using our stacks, right? I have already written the code down here for you for the sake of easiness, because I'm going to explain this problem to you. And just make sure you pay attention, because this covers a lot of principles around queue and also around the stack. And once you do this problem, you will be very comfortable with queue, the working of the queue, and also the problems or programs on how you should be approaching the questions regarding the queue and stuff like that, right? Hence, it is essential that you pay attention and focus right here, because this is a little complicated, right? It is, it is, it is really basic at the end, but understanding that part can sometimes be tricky and complicated, so make sure you pay attention. So starting with this, we'll first import our java.util.stack class for importing our stack class. uh, by the way, before we proceed, I would like to give you a small idea. We are going to be using queue, we are going to be using queue formation, and for that we are going to be like implementing the queue using our stack data structures. And basically we are going to be using two stacks, and the job for the first stack will be to enqueue the items in the queue, right? To store the items, and like just like just store them like stocking a pile. And the stack 2, on the other hand, will be responsible for serving the pile or for dequeuing the elements. So basically stack 1 will be like our input stack, and stack 2 will be like our output stack. So basically when these are combined, the stack 1 will basically help us in enqueuing the items into the queue, and the stack 2 will help us in the dequeue, right? Let's begin this. So we have the public class main, we have the static class which is queue using stacks. Then we define our first stack, that is initialized with integers, stack 1. And then we have another stack which is stack 2, which is also initialized with integers. And now we have two stacks, and we go on to here and we look onto the void enqueue function. It has int data, and it prints a statement that says system.out.println enqueuing plus data, right? So it is basically used for enqueuing the data. And then we have stack1 dot push data. So we are simply enqueuing our data into the stack1 by pushing it, because as you can understand, pushing and enqueuing are a lot similar, or they are the same, right? In the stack we push, in the queue we enqueue. So we enter our data here, that's our enqueue function. So for the dequeue we have int dequeue, and in this, if our stack 2 is empty, right, we check if our stack 2 is empty or not. If the stack 2 is indeed empty, we check if our stack 1 is empty or not. If stack 1 is empty, then our queue is empty and we are not able to remove anything, right? We are not able to dequeue anything, so we will not be able to remove something if the queue is already empty, or if both of the stacks are empty, you are not able to remove it. Well, if stack 1 is empty, you are not able to remove anything from the stack because it is already empty. However, as you can see, right, you can see this block of code. If stack 1 is empty, we do this, What if it's not empty? We go here, right? Because it doesn't go into the if condition, it goes on to the while loop. So while stack 1 is not empty, so we'll keep on running this. We'll keep on running the loop till stack 1 is not empty, and we will keep as long as this condition is satisfied. As long as the stack 1 has something inside it, we'll stack 2 dot push stack 1 dot pop. So as long as stack 1 has something, we'll be popping the elements one by one, one by one, one by one, and those elements we are going to be pushing into the stack 2, right? So stack 1 is used for input. It is already storing the items or the stock of file, and the stack 2 is currently empty. However, once the stack 2 is currently empty, we are taking the items or elements from stack 1 and we are putting them to the stack 2 for the removal of the stock of files, right? We're going to remove them, so we want to keep it ready for presentation, ready for removal, right? So until the stack 1 is empty, we push everything to stack 2 so that we can dequeue it later on. Now we have int remove function. We have int removed initialization, and in this the stack 2 dot pop, we removed our element when we popped the element from stack 2, right? And you know what this function is? Well, system.out.println dequeued plus removed. So basically it is removed. As you can already understand, stack 2 was for the dequeuing of the element, and once anything is popped from the stack 2, then it is removed, right? It is dequeued, then we return removed, right? Then we have the display function. In this we have the print statement, system.out.print q becomes, right? So this is an update state. This basically, I have added some additional print statements in this. In fact, I have added a lot of print statements. These statements will assist you in getting to understand the flow of control of the program. So whenever you see something that says q becomes, it basically means that there is a queue and that is going into the update state, that has gone through the updating stage, right? It has been updated, there has been a modification or a change in the values, right? This is just to give you an idea and keep it simple and easy for you. So in the display function we have q becomes if stack 2 is empty and stack 1 is empty, system.out.println empty. So if both of them are empty, you will be getting the output or print statement as empty. However, in the if stack 2 is empty and stack 1 is empty, we enter the empty condition. However, if that's not the case, our queue becomes, right, stack integer temp equal to new stack. So we are now again making a stack which is a temporary stack, right? It's just a temporary stack. In this we are basically applying a while loop that checks for a condition, and this is very important. If stack 2 is not empty, right, while stack 2 is not empty, as long as stack 2 is not empty, we are going to be performing the operation. What we are going to do, until the stack 2 is empty, we are going to temp.push stack 2.pop, which means we will be popping the elements from stack 2 one by one, and whatever the value is which is popped, we will push it in our temp, right? So pop from stack 2, push into temp, pop from stack 2, push into temp, until the stack 2 becomes empty, right? After that, once it becomes empty, we'll apply a for loop for integer item in temp. So whatever the integer items exist in our temp stack, we will add them to item, right? Okay, so the temp that we created, the stack named temp that we just created, whatever the items exist in the form of integer in the temp, we use these items, right? We print the statement system.out.print item plus space, right? So for each item that exists in our temp, we are going to print these items, right, until the stack 2 is empty, because we are popping the stack 2 and we are adding those items into the temp, and then we are simply printing these temp items. And after that, for int I equal to 0, I less than stack 1 dot size I plus plus. In this, we are running our loop starting from 0 and going on till I is less than stack 1 size, right, the size of the stack 1, and we'll keep on incrementing the value of I. And in this, we basically add the print statement or print command system.out.print stack1.getI plus space. In this, we are doing nothing, but we are simply using the stack1.getI. We are getting the value of the I, the current value, until we hit the stack size. So we are keep repeating to get the value of I, right? Keep repeating until we reach the stack size, stack 1 size, right? And after this, we have the system.out.println, right? Just taking a space. So while as long as the condition is satisfied, what's the condition? The condition is temp is not empty. So we are going to be keep on doing something. We're going to be executing an statement or condition until temp is empty, right? The temp was filled initially, but we are now going to do something, and we'll keep on repeating until the temp is not empty or is empty, right? Once it's empty, we are going to stop. What we are going to do, stack2 dot push temp dot pop. So we will pop items from the temp. We keep on popping, pop from top in the temp, and whatever we are going to pop, we are going to be pushing in stack 2, right? First, we took all the items from the stack 2, we put them in the temp, and then we took all the items in the temp and we pushed in the stack 2. So can you see what's happening? Once that happens, this was our display function, right? This was our display function, and once that's completed, once the display function completes here, we then simply have our public static void main. It's the default boilerplate code. We have queue using stacks queue equal to new queue using stacks, right? So we have created a queue which is named queue, and it is formed using the stacks basically. So in the queue, we enqueue 10. We have the enqueue feature. We enqueue 10. It will simply enqueue and push the data into stack 1. We enqueue 2. So the data 2 will simply be pushed into the stack 1. the data 30 will also be pushed. So these are all pushed into our stack. They are into the stack 1 now. So once they are there, we will display them. Once we get the display, right, we'll know if they have been properly pushed or not, if we are able to see them in the display. Once they have been in the display, we will dequeue, right? Once we dequeue, we will display again to check if the dequeue function works or not. If the element is shifted from our queue, if the function is shifted from our queue after we apply the dequeue method, then we can know for sure that the dequeue function works, right? After that, we see the display. The display tells us whatever is happening after our dequeue function. Then we have the print statement or print command that says before entering 40 and before enqueuing 40. So we are going to be enqueuing 40 in a moment, but before we do that, we will display queue, right? We will see how our queue looks before we enqueue 40. So the display should not have 40, right? Because 40 is not yet enqueued, so display should not have 40. But after we do, we enqueue it, right? We enqueue it so that it goes into the list. After that, we have the print statement that says after enqueuing 40, and then we have the queue.display, which would display the results after the enqueuing is done. Let's run this code now. As you can see, the enqueue is done for the 10, 20 and 30. After that, we have the updated state of our queue. The queue becomes 10, 20, 30. Then we dequeue 10. After dequeuing, the queue becomes 20, 30. As you can see, 10 is removed. It is dequeued, right? So pay attention here. 10 was first to be queued, so it was first in. And when we dequeued, the 10 is dequeued, so that is first out. So we are following the first in, first out principle. That is the principle for the queues and not stacks, right? So we are following the right principle. After this, the queue becomes 20, 30. So the dequeue has successfully been done. And then we are going to enqueue something again, right? We are going to enqueue something again. So before enqueuing 40, our queue looks like this: 20, 30, just like it was before, 20, 30, 20, 30. Then we're gonna be enqueuing 40, so we enqueue 40, and once we enqueue 40, we have after enqueuing 40, the state that becomes after enqueuing of the 40, the queue becomes 20, 30, 40. So as you can see, first 10 came, then 20, then 30. So 10 is gone, then 20, then 30, then 40 comes at the last, which means 40 is the last to be entered in, and hence it will also be the last to be removed. That's how our queue works. I hope you were able to understand this function, and thank you for watching the video.